Okay, so I'm picking up exactly where I left off in the previous video, which is part 1 of global illumination. Alright, so we got global illumination working. We set up our light. Our room is set to receive and bounce around the photons coming from the light. Now, we see that we have this artifact, and how do we fix that? That's going to be the focus of this video. I'm going to focus on render times as well as optimization. So let's go ahead and get started. We have a lot to cover. Okay. Over here in the light, we have one parameter, just one, that's going to go ahead and control the quality of the render. And that's the number of global illumination photons down here. By default, it's set to only 10,000. 10,000 is too few global illumination photons. That is not enough. It's good for doing preview renders, but it's not good for a production render. As I lower this number, say to 1,000, which is a very small amount of photons, the photon illumination gets so bad to the point where we can actually see the individual photons from the light. That's how few photons we're using. That's the small number of photons that we're using at the moment. Okay. Now what I'm going to do is I'm going to go ahead and open up my render settings, and in the global illumination section here we have a few parameters. Now these parameters, most of them are going to affect the quality and the speed at which this effect renders at. The first parameter we have here is accuracy, and by default it's set to 500. 500 is actually very low accuracy. So what's the accuracy parameter? The accuracy parameter controls the accuracy of the global illumination effect, for lack of a better explanation. No, actually I do have a better explanation. And the explanation for accuracy is the following, okay? The accuracy, the lower it is, the less accurate the global illumination effect. You can see as I drop it, the global illumination effect doesn't appear to change at all. If I increase it all the way to 1,000, it still doesn't seem to get any better. If I increase it to, say, 2,000, it still doesn't get any better. So, is the accuracy setting broken? Why is it not working? Well, that's because the accuracy setting can only do its job when there's enough photons for it to actually make a difference. Since we're using only 1,000 photons, which is a very small amount, and just to give you an idea, a good photon map, if you're only using global illumination, should probably consist of maybe 6 million photons, something like that. So you need millions and millions of photons to make a global illumination effect in the scene actually look pretty good. Editor, edit that out of the video. Actually look pretty good. So right now we're only using 1,000 photons for our entire scene, which is too few photons. So let me put this back down to 500. Then we have scale. Scale does not affect the render time, and it does not affect the quality. All it does is it affects the brightness and even the color of the global illumination. So if I change this to red, you'll notice the global illumination now turns red, and just the photons turn red. The light is still white, the area light, but the photons are now red. If I wanted to, I can make the photon effect brighter or dimmer. If I take this value setting, editor, edit that out of the video, starting again in 3, 2, 1. If I take this value setting down here and take it to below the default, which is that's the second time I lose my voice in a row in a span of just about a minute. So I think my voice is getting kind of strained here. I'm going to give it one more go. If that happens again, I'm just going to end recording for today, and we'll pick up tomorrow where I left off. Okay? Okay. So start again in 3, 2, 1. Alright. Down here I have in my color chooser, I can switch from RGB or HSV. Let's switch to HSV if you're not already there. And you notice down here we have a V parameter, V which stands for value, and the parameter by default is set to 1. If I reduce it to about halfway, you notice that the photon effect becomes dimmer and dimmer and dimmer. I can also overdrive this parameter past 1, believe it or not. If I go ahead and just type in a number like, say, 2, the light becomes much, much brighter. And that's the light from the photons. It's not the area light itself. It's just the photons becoming much brighter. If I increase that to 5, you notice now they become way too bright. So let me go ahead and put that back at the default, or I'll just hit cancel. And you see how the scale works. Now the radius. The radius controls the size of these photons. If you notice, you can see the individual photons overlapping each other, and they just look like big circles spray painted on the walls by some kind of crazy graffiti artist running around our scene here, spray painting everything. Okay? With a radius set of 0, which is the default setting, by the way, what this does, it tells mental ray to look at your scene, look at the size of your scene, and automatically guess what size would be good for this scene. Okay? So that's what putting the radius to 0 means. Putting the radius to 0 basically hands over control of this parameter to mental ray. But we can overdrive this parameter and control it ourselves. For example, we can set a radius of 1, and now you notice that the little circles there of the photons become much smaller. And we can go even smaller, to 0.1. Now they become essentially little dots. They kind of look like little star stickers that some kid stuck all over our room here. And if we increase to 5, we get a much bigger size, which looks actually just like putting it to a radius of 0. So I guess mental ray was using the setting of about 5 when I gave it control. Okay, so here's 2. Okay, so we can see the photons pretty good. Alright, what is this merge distance parameter? Well, when you're using millions and millions of photons, you end up with a photon map, and we'll talk about that in a moment. If we go down here to Photon Map, you notice that we have some parameters here. Okay, I'll go more into detail with this in a moment. Right now, let's continue talking about this. Okay, now with global illumination, we have this merge distance parameter by default set to 0. 0 basically turns this feature off. So what does that feature do, merge distance? Merge distance is going to look at the scene, and based on the parameter that you put right here, it's going to go ahead and decide, these two photons are close enough together to the merge distance threshold, so I'm going to go ahead and I'm going to merge those photons together. Now, there's an upside to that, and there's a downside, like with anything in life. Let me show you. Let me put the merge distance to 5. You'll notice that now we have less photons. The good thing about using the merge distance is that you can actually merge photons that are close within this distance here of 5. What that means is that the final photon map won't have as many photons as before, which makes for a smaller photon map. The smaller your photon map, the better off you're going to be, especially if you're doing a network render over a render farm or several computers, okay? Because it means that that a smaller photon map is going from computer to computer, which is a better, more optimized way of rendering with mental ray, okay? Now, in my personal opinion, I don't like to use the merge distance parameter. I like to keep it at 0 to turn that feature off. The problem with the merge distance is that by merging some of those photons and getting rid of them, what happens is you end up with a lot of blotching and a lot of spots all over your scene that are missing photons, and that will not look good. We'll basically end up back with a scene that looks like an old apartment that had a fire in it recently, okay? Alright, so what does the radius do? Let me come back to the radius really quick. If we put it to 0, mental ray determines the radius automatically. If we take that radius and crank it up to something like 20, the first thing you notice is that, wow, this looks a lot better than before. We don't have as much blotchiness, and we can't see the photons. Well, if we increase the radius to, say, 40, it looks even better, right? Well, don't be deceived. This is very, very deceptive. Although this may look pretty good, there's something drastically wrong with this scene. And although it's very hard to tell to the untrained eye, the thing that's missing from this scene is physical accuracy. We cannot, and I'll say that again, we cannot make up for using only 1,000 photons by coming over here and increasing this radius to a very large amount. By doing that, you're sacrificing the physical accuracy of the photon lighting in the scene. And that's not good because you end up losing realism. Okay? So what you want to do, the idea is to use as tight a radius as possible. Because the smaller the radius, the more accurate the render is going to be. Because you have the smaller photons that can fill in smaller areas, and it's just going to be a much more accurate result. Okay? Now, when you do lower the radius, you end up with this, which doesn't look very good. So how do you fix that? Well, that's where a few other key factors come into play, including the number of photons. But this video has been going on for a pretty good while now. What I'm going to do is I'm going to end this video here, and in the next one I'm going to continue here with global illumination and photon mapping in mental ray.